As our third assessment, we are assigned to do a video assignment and the topic given is about application of differentiation. But first of all, let me introduce you guys to our group members. Our group consists of 4 members. The first member is me, Sabha, and then we have Diana, Aisha, and last but not least, Anissa.
Assalamualaikum warahmatullahi wabarakatuh. This is prepared for Madam Ashura. We are really grateful because we managed to complete this video presentation within the time given by our lecturer, Madam Ashura. This assignment is impossible to be done without the great cooperation and effort of our group members. We also sincerely thank our lecturer of Calculus 1, Madam Ashura, for the guidance and willingness to help us in what we are lacking when completing these assignments, and surely for teaching us this course.
What is differentiation? Differentiation is a method used to compute the rate of change of a function f(x) with respect to input x. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. Application of differentiation. There are 6 applications of differentiation. First, total differential and linear approximation. Second, related rates. Third, graph, which is polynomial and rational function. Fourth, maximum and minimum problem. Fifth, mean value theorem. And lastly, Rolle's theorem. What is maximum and minimum problems? Maximum and minimum problem is the process of finding maximum or minimum value is called optimization. For example, maximize the profit in a company, maximize the cost, or find the least amount of material to make a particular object. How to solve maximum and minimum problems? First, draw and label diagram if necessary and identify info. Second, find the first derivative test, which is f(x) equal to 0. Third, use second derivative test, which is f double prime x more than 0 is minimum value, meanwhile f double prime x less than 0 is maximum value. And lastly, solve the problem.
So, here is the problem. The diagram shown is a window in the shape of a rectangle with a semicircle on the top. The window also has a perimeter of 4 meters. For this problem, it has 3 sub-questions. The first one is to express h in the term of x. Next, we need to show that the area of the window is given by a, which equals to 16x minus 4x squared minus 5x squared divided by 8. And the last question is determine the maximum area of the window.
So this is how the problem is going to be solved. For the first question, we need to find the arc of semicircle firstly, so that it will be more easier to find the perimeter equation. The formula for the semicircle is pi d over 2. So for this problem, the diameter for the semicircle is going to be x. So it will be pi x over 2. Next, we can state the perimeter equation. The perimeter equation is x plus 2h plus pi x over 2 equals to 4. So then, we need to eliminate the denominator for the pi x over 2. So we need to multiply the equation by 2. Next, we're gonna multiply the equation. 2x plus 4h plus pi x equals to 8. So using the algebra function, you need to transfer the x so that the h can be looped. So it will be 4h equals to 8 negative 2x negative pi x. Next, we're going to transfer the 4 so the h is going to be looped. So it will be h equals to 8 minus 2x minus pi x over 4. So that's how we find the expression for the h in terms of x. So for the question B, the question asks us to show that the area of the window is given by A equals to 16x minus 4x power square 2 net minus 5x power square 2 over 8. Firstly, we need to find the area for the rectangle. It's easier for you to draw it first. So the area for this rectangle is equals to x multiplied with h. So then we're going to make the area for the semicircle. The length for the semicircle is x. So using the formula, pi multiply with radius all squared 2 over 2. Then the radius for the semicircle is x over 2 because it's divided by 2, right? Because x is the diameter. So it will be pi multiply with x over 2 small square 2 over 2. So to make it easier, we make the x over 2 whole square is going to be pi x whole square 2 over 4 over 2. So to balance it, the equation now will be multiply these two. It will be pi x whole square 2 over 8. Then to find the area, we need to total the area from the rectangle and the semicircle. Next, we transfer it. xh plus pi x whole square 2 over 8. Next, we're gonna include the h in the equation from the previous question, which is the a equal, the h is equals to a minus 2x minus pi x over 4. Then we multiply it. It will be 8x minus 2x whole square 2 minus pi x whole square 2 over 4 plus pi x whole square 2 over 8. So there is two fraction right here. So we need to make it into 1. So we're going to multiply the first one with 2, so that the 4 multiplied with 2 is going to be 8. Going to be same with the second fraction. Now we're going to solve it. Now look at the question. The question is the same, right? So the area that was shown is a equals 16x minus 4x whole square 2 minus pi x whole square 2 over 8. So now we got the same one, so it has been shown. So for the last question, the question asks us to determine the maximum area of the window. So at first we need to list off the area equation first, so it will be easier to look at it. 16x minus 4x whole square 2 minus pi x whole square 2 over 8. Then we simplify it. It will be 60x over 8 minus 4x whole square 2 over 8 minus pi x whole square 2 over 8. Then it will be 2x minus 1 over 2 x whole square 2 minus pi x whole square 2 over 8. Then we do the derivative test. It will be dA over dx. 2x gonna be 2 minus 1 over 2x whole square 2 gonna be x. Pi x whole square 2 over 8 gonna be 1 over 4 pi x over x 1. Then we let the derivative equals to 0. 2 minus x minus 1 over 4 pi x equals 0. Then we solve it. X plus 1 over 4 pi x. Then we simplify the a for dx. Multiply with 1 plus 1 over 4 pi. Then we let the x to be alone. It's gonna be 2 over 1 plus 1 over 4 pi. Yes. Then we need to do the second derivative test to see that if it's a maximum or minimum value. D whole square a dx over dx whole square 2 equals to 0 minus 1 over 4 pi. Yeah, then we solve it. It looks like the second derivative test is less than 0, so it will be maximum value. So x equals to 2 over 1 plus 1 over 4 pi is the maximum value. So the x equals to 2 over 1 plus 1 over 4 pi is going to be included in the area equation. So it will be like this. Area maximum value equals to 16x minus 4x whole square 2 minus pi x whole square 2 over 8. Then we include the x in it. 16 multiplied with 2 1 over 4 pi minus 4 multiply this 2 over 1 plus 1 over 4 pi whole square 2 minus pi multiply by 2 over 1 plus 1 over 4 pi over with 8. Then we calculate it, we're gonna get it. This 1.12 meter square. So that's how we solve the C question.
For the conclusion, by applying this differentiation method into this problem, We can conclude that the application of differentiation can be used to define a value of an area, solve any other kinds of problems, solve problems related to value of an area.